that the one of the very interesting behavior of quantum mechanical approach, that if we are talking about a particle, and if we are talking about the free particle itself, it is a very simplistic particle, we can say. Then what we have, the particle is not well localized in a space, rather it is extended from minus infinity to plus infinity. So you can represent your state, quantum mechanical state of a system by basically some extended wave from plus infinity to minus infinity. So today we will again see some different property of quantum mechanical approach, mainly some different observation. But before going to that, let us try to go for one concept, that is basically probability current density. Probability current density. Okay. So what is probability current density? So before going to probability current density, we will just try to learn what is current density. And this is one of the very fundamental theory from the electromagnetic theory, basically, that we have a basically continuity equation, d rho upon dt plus del dot j must be equal to 0. This is one of the very famous continuity equation. It can be used into electromagnetic theory. It can be used into your statistical mechanics. It can be used into your mechanics, fluid mechanics. So everywhere you can have this particular continuity equation. What is tell you? It just tell you that flux, whatever is the incoming flux, is exactly going to the outgoing flux. So this will be some sort of conservation of flux, or conservation of you can see, if you are talking about statistical mechanics, then you can talk about conservation of mainly that number of microstate, or if you are into the fluid, you are just talking about the amount of fluid that which is just passing through one particular region, will be just whatever is the coming, that will be exactly going one. So that is different issue. This is all about continuity theorem. That will very important thing. And this continuity theorem also work into the quantum mechanics. What is meaning of this? Now, in an electromagnetic theory, what you have seen that current density J is nothing but equivalent to rho into V. And if you are talking about current density, that is your J as a vector quantity. Rho is nothing but charge density. V is the velocity of a particle. Everyone is comfortable into this? But if you have charge density, it is not necessary you have current density, unless until your charge is time varying, or you have charge which is moving with velocity v. Both are same thing. If charge is varying with the time, that is different issue. And if it is moving with some velocity v, that is different issue. But both will contribute to the current. Everyone is comfortable with this basic concept?
Yes, sir.
Yes. So similarly, in a quantum mechanics, we have one-dimensional current density. And this current density is basically h cut upon 2im psi star del psi upon del x minus psi del psi star upon del x. This is definition of current density. Now, if I have, suppose current density psi x, and I am just talking about the free particle. Free particle, if I am talking about, that means the particle have some momentum associated with this. And let us assume that particular that particular particle is e to the power I kx. Now, can you please tell me what will be momentum associated to this particular particle, this particular wave function?
H cross K.
Very good. So h cut k is the associated momentum. Now, what will be the probability density? Mod psi square, mod a square, isn't it? And now, if I am going to put this equation here, what I will get? I will get h cut upon 2im psi star is nothing, a star e to the power minus ikx. If we are going to differentiate with respect to x, then we have a ik e to the power ikx minus this psi will remain a e to the power ikx. We are going to differentiate psi star. So if we are going to differentiate psi star, we have a star minus ik e to the power ikx. Yes, everyone is comfortable? है ना?
Sir, e to the power minus ikx.
E to the power minus ikx. Thank you. So this is my expression, and now you can see this will be h cut upon 2im, and this thing is nothing but ik into mod a square, and this minus minus is plus, and again you have ik into mod a square, and this value is equal to h cut k upon m mod a square. Is that okay? क्लियर है ना? सही आ रहा है? देखो तो कैलकुलेशन से.
Yes, sir.
And what is this particular j? Your j is, or you can write jx here. So what is your jx here? Your jx here is equal to h cut k upon m mod a square. And what is mod a square?
Mod psi square.
Mod psi
Probability
square.
density.
So mod a square is nothing but the mod psi square, which is probability density. And what is h cut k?
Momentum.
Momentum by mass. So this is nothing but what? Velocity. Isn't it? So now you can see you have exactly resemblance of this particular expression from the electromagnetic theory. है ना? What is this rho? What is this rho? Charge density. What is this v? Velocity of that
Velocity.
particular charge. What is this mod psi square? Probability density. What is the v? V is the velocity of a particle. So that is exactly same thing. And now you can see I can have current density which is 0 when my velocity of a particle is equal to what? 0.
0.
Okay. Now, if I am going to take some another wave function, let us go for this wave function, and this wave function is a e to the power minus alpha x square, where alpha is positive quantity, is real quantity, a is your normalization. What will be current density there?
0.
0. So your current density is equal to 0. What will be your probability density? Your probability density is mod a square e to the power minus 2 alpha x square. This is your probability density. So now you have probability density, but your current density is 0. What is meaning of that?
Sorry, sir, why we are taking this current density 0?
Because
Sorry.
psi star is equal to psi. This is a real function.
Okay.
Okay. So psi star is equal to psi. This is a real function. So you can easily calculate. You can put it here. You will get current density is equal to 0.
Okay.
Okay. So what is, so this mod psi square is equal to mod a square e to the power minus alpha 2x square. So now you can see you have probability, you have current density which is 0, but probability density is not going to 0. What is meaning of that? Which quantity is going to 0 here?
Velocity.
Velocity of a particle is going to 0 here. Isn't it? So when your velocity of a particle is going to 0, that means you are into the classical forbidden region. Yes? Where you have real velocity. When your momentum is, when you have some kinetic energy, isn't it? ये चीज समझ में आ रहा है या नहीं?
Yes, sir.
So when,
Forbidden का नहीं समझ
sorry,
forbidden region का नहीं समझ में आया.
forbidden region means where particle cannot be classically exist.
Okay, that is clear. But in this case, how forbidden region comes?
Because velocity is 0. So if particle classically is not going to exist into that region, that means there is not any velocity, isn't it? Huh?
Not getting it, sir. Means
Why not getting it? I am telling you, in which region your velocity is 100% 0.
velocity is 100% 0.
In which region your velocity is 0?
This will means not possible. Na forbidden region.
That is in the forbidden region.
Forbidden region.
So
Okay.
if you are into the forbidden region, classically your particle is not allowed to move into that region, isn't it?
Yes.
So if your particle is not allowed to move into that region, that means your velocity is equal to 0.
Yes. Clear, sir.
For example, suppose I have this sort of potential and I have this much of energy. Is that classically you can exist into this region?
No.
No, sir.
No, you cannot exist into this region. Is that classically you can exist into this region? No.
No.
Classically you can exist only into this region. Why? Because your total energy is greater than potential energy.
Right.
That implies your kinetic energy is greater than 0. Isn't it? This is all
Yes.
about classical allowed region.
Yes. Yes.
So, but look at the thing. Even if your velocity is 0, into that region, there is finite probability that your particle can exist into that region quantum mechanically.
Yes, sir.
समझ में आ रहा है? ये बहुत ही इंटरेस्टिंग बात हो रही है. What I am trying to say, classically your particle cannot exist into this region and this region, but quantum mechanically your particle can exist into that region also, because you have probability density and this is your probability density. Are you getting my point? Now I am giving you one homework. Just tell me, if I have psi x is equal to a e to the power minus alpha x square e to the power I kx, then what should be your probability density? Suppose this is my wave function, then what should be your probability density?
H cut K by M.
Probability density.
Square to e raised to minus 2 alpha x square.
So your probability density will be, you have mod a square e to the power minus 2 alpha x square. And can you guess what should be your current density in this case?
Yes, sir. H cut K by M.
Yes,
and
very good.
probability density.
Very good. H cut K by M and probability density. Are you getting my point? Minus 2 alpha square. So this will be your current density. So this is your homework, that you have to prove this expression. You will find this value will hold there. So why there is now look at here. This probability density and this probability density is exactly same, isn't it?
Yes.
Yes, sir.
But
Yes.
but here current density is 0, but here current density is not equal to 0. Why?
Because of
For this e to the
function.
power exponential factor, extra factor.
Because
e to the
this
power
factor,
IK.
because this factor. And whenever momentum come into picture, that means you are into which region? Classical allowed or forbidden region?
Allowed region.
Allowed region. So
Allowed
whenever
region.
momentum come into picture, the particle is moving in a classical allowed region, you have this factor associated to your wave function. Yes? Because this is the eigenstate of momentum. With what eigenvalue? H cut k. Now, can you please tell me what will be current density for this wave function? What will be current density for this wave function without going to calculation of using formula? Just बताइए.
H
Mod A
cross
square.
A up
What will
into
be current density here? क्या होना चाहिए?
mod A square
Mod A
Minus.
square
into H cross K by M.
minus h cut k upon m.
Minus, yes.
Why? Because current density is a vector quantity. So you have to take care of the negative sign. How much momentum is associated with this particular wave function?
Minus H cut.
Minus h cut k. And now you have this, and this current density will tell you that if I am talking about this one is positive one, then this current density will tell you this is all about negative one. And now we can have superposition of different wave. So suppose I have psi x is equal to a e to the power ikx plus b e to the power minus ikx. What will be current density? What will be current density here?
H cut k upon m.
H cut k upon m.
A square
A square
plus b
plus
b square. B square.
plus mod b square
Yes, sir.
and
Minus H cut K upon M.
very good minus h cut k upon m. So this current density is h cut k upon m, and you have mod a square minus mod b square. Now, next one is very tricky. If your psi x is a e to the power ikx minus b e to the power minus ikx, what will be your current density?
H cut K upon M mod A square.
Yes.
Very good. H cut k upon m mod a square. Very good.
Minus of H cut K upon M mod B square.
No, sir.
No,
Plus B.
that is plus mod
Mod of B.
minus mod b square minus h cut k upon m. Because in a wave function you have always superposition, and in a superposition nothing to do with this negative sign. This is something like plus minus b. Are you getting my point?
Yes.
So what will be your current density? H cut k upon m. You have mod a square minus mod b square. Both have exactly same current density. Because this current density and this current density, what will be current density associated to this one? This one. What will be current density associated to this one? This one. So you have to always try to talk about the superposition principle. And if examiner will give you something like minus b, you have to write it in a superposition form. Are you getting my point? प्लस या माइनस वो कहां से डिसाइड होगा? दैट विल डिसाइड विद द मोमेंटम पार्ट, नॉट विद द एम्पलीट्यूड पार्ट. आर यू गेटिंग माई पॉइंट?
Yes, sir.
सपोज एक और कर लेते हैं. a e to the power I kx plus ib e to the power minus I kx. What will be your current density? बताइए.
H cut k by m modulus of H cut k by m modulus of a square plus I modulus of iv square
Modulus of ib
minus of
square
H cut
minus h cut k upon m.
into minus H cut k by m.
Very good. So again you will get the same thing, है ना? Modulus
Yes,
of
sir.
ib is equal to what? b square,
Only v square.
है ना? So what you will get? Again you will get h cut
Yes,
k
sir.
upon m mod a square minus mod b square. Everyone is comfortable? Okay. So now this is a basic concept of probability current density. And if you are getting some current density, that means you are into classical allowed region or forbidden region?
Allowed region.
Allowed region. And if you have current density which is not equal is 0, that means your particle is in allowed region or forbidden region?
Forbidden.
Forbidden region.
For
And there is
boundary
not,
region.
and everywhere you have some mod square, isn't it? Either it in the allowed region or into the forbidden region. Okay, good. So now let's try to go for a very interesting system, and that system is step potential. And let's see what is going to happen quantum mechanically when my particle is going to interact with step potential. So let me first define what is my step potential. Just a minute. So what we have Vx is equal to 0, x is less than 0, basically, and is equal to V naught, x is greater than 0. So you can assume something like this, a step kind of thing. है ना? This is your V naught, and this height, sorry, this is 0, this height is V naught, and you can have all up to minus infinity and plus infinity. Now, classically, let's see what is going to happen. Suppose my energy E is greater than V naught. Suppose energy E is greater than V naught, then what will happen? If I am trying to throw the particle from left, is that particle will cross the barrier? Across the step?
Yes, sir.
Yes?
Fine. Probability.
Huh?
Yes, it will cross.
Suppose I am thinking classically, that means I am throwing a marble ball. And if I am throwing a marble ball, it will coming from here with some momentum. At this point of time, its momentum will reduced. Why? Because we have potential, and then it is crossed. Yes? And suppose I will throw 100 number of marble, then all the 100 number of marble will cross if my energy is greater than V naught.
Classically.
Yes,
If I am
sir.
talking about marble, I am talking about classical. Yes?
Yes, sir.
Yes. But the same experiment is actually conducted by some atomic level particle or electron or proton. What we have observed? We have observed that some, even if energy is greater than V naught, some particle will reflect back. So how it is going to happen? And in another way, if I am throwing 100 of electrons, at least 3 and 4 electron is going to reflect back. And if my energy of electron is very much comparable to V naught, then chance of reflection is high. But if my energy is greater than V naught, very, very greater than V naught, then chance of reflection is low, but you cannot say that particle is going to 100% transmit to this particular region. This is very weird nature, isn't it? How we can explain it? So quantum mechanics come into picture and we can explain the whole thing. So let's try to go for a. So this is my region 1 and this is my region 2 because E is greater than V naught. What we have to do? We have to solve Schrodinger wave equation into region 1 and region 2. So what is your Schrodinger wave equation into region 1? Minus h cut square upon 2m d square psi 1. Why I am writing psi 1? Because it is in region 1. X square.
1,
What is potential into that region?
0,
0.
0.
Psi 1 is equal to E psi 1. You have exactly same function. You have exactly same equation as we have solved into the last class, है ना? So we can write d square psi 1 upon dx square plus k1 square psi 1 is equal to 0. What is value of k1? Root under 2m e upon h cut square. So this is value of k1. What is solution of this one? बताइए क्या solution होगा?
Minus IK.
Very good. So you have two solutions are possible. A e to the power I k1x plus B e to the power minus I k1x. Isn't it? So this is the wave function into region 1. So let us try to go for wave function into region 2. Obviously, E is greater than V naught. So let's go for Schrodinger wave equation into region 2. That is h cut square upon 2m d square psi 2 upon dx square plus what is your potential here? V naught
V naught,
psi 2 is equal to E psi 2. And we can easily solve it. D square psi 2 upon dx square. And this value is equal to 2m upon h cut square E minus V naught psi 2 must be equal to 0. देखो ठीक लिखा हो ना? This negative sign will here. This negative will be here. It will come to this side. So this will be positive and V naught will be negative. Everyone is comfortable?
yes sir.
Okay. So now I can go for d square psi 2 upon dx square plus k2 square psi 2 is equal to 0. What is value of k2? 2m E minus V naught upon h cut square. So what is your psi 2? बताओ क्या होगा? C e to the power I k2x plus D e to the power minus I k2x. Everyone is comfortable?
Yes sir.
है ना? Okay. नाउ यहां तक देखो, कुछ पूछना है तो पूछ लो, फिर हम लोग इसे एनालाइज करेंगे क्या हो रहा है एक्चुअली। एवरीवन इज कंफर्टेबल, है ना? ओके। So we have this particular step potential. This height is V naught. This is 0. I have psi 1 a e to the power I k1x plus b e to the power minus I k1x. I have psi 2 c e to the power I k2x plus d e to the power minus I k2x. Everyone is comfortable? हाँ या ना? Now,
Yes, sir.
Yes.
chalo. Now, is that in this region we have higher velocity and in this region we have lower velocity? Yes or no?
Yes, sir.
Yes, sir.
Yes. In this region you have high momentum, in this region you have low momentum. Okay. Now, so this is something like a two interface or two medium kind of thing. If you are trying to analyze with the optics, ray optics basically. जैसे I am just giving you, suppose this is medium 1, this is medium 2, and medium 2 is more dense. So that means if light particle have higher velocity in medium 1 than the lower velocity in the medium 2, isn't it?
Yes, sir.
Yes, sir.
Yes. Similarly, my particle is higher velocity into medium 1 and the lower velocity into the medium 2. Yes.
यहाँ पोटेंशियल है इसलिए हम ऐसा बोल रहे हैं ना, मतलब
बिल्कुल यहाँ ऐसा बोल रहा है, पोटेंशियल इसलिए ऐसा बोल रहा है।
थैंक यू सर।
ठीक है, बिकॉज दिस इज योर पोटेंशियल, यू हैव डिफरेंट मोमेंटम। व्हाट इज मोमेंटम हियर? आप यहाँ इजिली लिख सकते हो, p स्क्वायर अपॉन 2m is equal to e. So here momentum is equal to root under 2me classically. And what is momentum here? So you have p square upon 2m plus v naught is equal to e. So p is equal to root under 2m e minus v naught. Yes. So now I am just asking you, if this is my incident wave, the reflected wave have same momentum or different momentum?
Same
Different.
momentum.
डिफरेंट
And momentum.
In term of magnitude,
So same momentum.
same momentum, because it reflected wave will find into the same region in which incident wave is there, isn't it?
Yes, sir.
Okay. And the direction of incident wave and direction of reflected wave will more or less opposite.
Yes, sir.
Yes, sir.
Yes. And if particle is going, or if light is going to transmit, that means this light wave have different momentum than the incident one.
Yes, sir.
Yes.
यस सर।
Okay. Unless until there is not any third interface, there are not any reflected wave into the region 2.
Yes, sir.
Yes. So now, if I can consider look at this is very interesting. If I can consider psi incident is a e to the power I k1x, then what will be my psi reflected?
B e to the power minus
B
I
minus-
k1
So psi reflected is b e to the power minus I k1x. And what should be psi transmitted?
C e to the power I k2x.
I
c
K.
e to the power I k2x. And what about this one? Is that in this particular two interface case, this one has any physical relevance?
No.
No, sir.
No. This has not any physical relevance. That means D must be equal to what? 0. Yes?
Yes, sir.
भाई आपको अपने मैथमेटिक्स को फिजिक्स के अनुसार लेके जाना होगा ना? You
Yes.
have to resemble your mathematics with the physics. तो फिजिक्स तो ये कह रहा है कि there is, if particle is crossing, then it is crossing. It is never chance. Once it is crossed, it will never go back. अब जैसे यहां पर है, एक बार ट्रांसमिट कर गया तो कर गया. Are you getting my point? Okay. Everyone is comfortable up to this?
सर ये इंसिडेंट
Yes, sir.
रिफ्लेक्टेड वाला कैसे लिखा?
I have just assumed that particle is coming from this side with some positive momentum. So this is my incident. This is basically superposition of different wave. I am just trying to see physically which one is the which wave. So particle positive momentum लेकर इधर से इधर आ रहा है. So which one is incident? I assume this one is incident. Once I assume this one is incident, then what should be my reflected? Reflected wave किस region में होना चाहिए? Region 1 में या region 2 में?
रीजन 1 में.
So this is your region 1. So this should be identified as what? Reflected.
यस सर.
And what should be transmitted?
रीजन
Transmitted have same sign of the incident. So this is my transmitted.
सर समझ गए. ओके सर.
Clear है?
यस सर.
Suppose my particle is going from here to here. Then I assume this one is my incident. Yes?
यस सर.
Then which one is my reflected?
C to the power I k2x.
Very good. Then which one is my transmitted?
B to the power minus I k1x.
Then which should be A? Which should be 0?
A.
A.
A should be 0. This is logical. Just it. That's it. है ना?
Yes sir.
Okay. Now, what will be current density associated with incident wave? बताइए.
mod square h k by m.
H k1 upon m.
K1, yes, sir.
What is current density associated with reflected one? Mod
B square minus h
minus
cut k1.
h cut k1 upon m. What is current density associated to transmitted one? Mod c square h cut k2 upon m. Now we have two different parameters. The first parameter is reflection coefficient, and this is some sort of ratio. What is this reflection coefficient? And if I am talking about current density, that means I am talking about basically intensity, isn't it? Yes or no? In a wave, this is and the current density is analogous to what? Intensity. This is proportional to amplitude, isn't it? Amplitude square. And what is intensity? Intensity is
Amplitude
proportional to amplitude square. You remember all this thing?
Yes, sir.
Yes sir.
Yes, sir.
So why I am also saying it intensity. Okay. So now the reflection coefficient is basically JR by JI. And what is your JR by JI?
mod b square by mod a square.
Mod B square by mod A.
So mod B square upon mod A square. What is your transmitted? This is identified as J transmitted by Ji. What I want to know, I just want to calculate how much intensity we are giving and how much intensity it is just going back. Something like this. If you are trying to resemble it with the wave. And if you are trying to resemble with the particle, then out of 100 particle, if I am throwing 100 particle, how many particle is going to reflect back and how many particle is going to transmit? And all particle have same energy E. Are you people happy? Okay. So this value is equal to mod C square
Upon mod A
K2
square.
mod A square
K1.
upon K1. यहाँ तक clear है?
Yes, sir.
The whole idea is that I have to calculate B by A ratio and C by A ratio in a term of V0 and E, isn't it? Because that is only thing we know. What is my energy and what is my barrier potential for the barrier? Clear है ये?
Yes, sir.
Okay. So what we will do, we will just try to use boundary condition. So obviously, the solution of Schrodinger wave equation must be continuous as well as it should be also differentiable. And square integrability is another thing that will obviously come into picture when we will go into bound state. But when we are not into bound state, square integrability is not a big question. Okay. So if I am talking about continuity, and obviously D is equal to 0, so it has not any relevance. So what I have psi 1 at x is equal to 0 must be equal to psi 2 at x is equal to 0. And we have A plus B must be equal to C. Everyone is comfortable?
Yes, sir.
Okay. And second equation is d psi 1 upon dx at x is equal to 0 must be equal to d psi 2 upon dx at x is equal to 0. So what we will get from here? A ik1 is there, ik1 is there. So A minus B ik1 must be equal to ik2c. सही लिखा हूं? देखो तो जरा. So I have two equation. A plus B is equal to C and A minus B is equal to K2 by K1 into C. And if we are going to add it, then I can get C by A is equal to, क्या हो जा रहा है? 2 K1 plus K2 ऐसा आ रहा है क्या? Just check it, just check it. I am just going to add it. मिल रहा है ये?
Yes, sir.
Yes, sir.
So I have transmission coefficient and the transmission coefficient is nothing but C by A. So that value is 4 K1 K2 K1 plus K2 whole square. And I can put value of C here and I can get the value of B by A. मिल जाएगा ना? So I am just writing B by A and that is nothing mod B by A square is equal to, you can check K1 minus K2 K1 plus K2 whole square. So you have, and if you are going to check R plus T, what you will get?
Sir, 1.
1.
1.
That means either your particle will reflect or it will transmit. Isn't it? Either your particle is going to reflect or it is going to transmit. So this is basically we can get the reflection coefficient and transmission coefficient. In the next class, we will discuss what is actually going to happen and how we can understand this particular thing. So I am just giving you one homework. So I can put value of K1 and K2. So that value is equal to root under E minus V naught, root under E plus root under E minus V naught whole square. So what you have to do, you have to just calculate the value of R for E is equal to 2V naught. Okay. And value of R for E is equal to 1.01 V naught. Calculate करके रखोगे इसे by the help of calculator? Yes?
Yes, sir. Yes, sir.
Just try to calculate it.
सर ये इक्वेशन कैसे सॉल्व करिए?
कौन सा इक्वेशन कैसे सॉल्व
a
करिए?
प्लस बी a माइनस बी
मतलब
ये c बाई a कैसे आया सर?
भाई दोनों को ऐड कर लो.
यस सर बट
अब-
सर c बाई a
हाँ क्या सी बाई ये क्या है? ऐड करके देखो तो. अरे बाबा 2a इज
ओके
इक्वल
ओके
टू
आ गया सर आ गया.
आ गया कुछ तो
सर आई
करना
मिस
चाहिए.
द
हाँ?
c. यस सर.
मैं दिमाग में कर लेता हूँ. ठीक है. हर चीज मैं थोड़ी करूंगा. बीच का स्टेप तो खुद करना पड़ेगा आपको, है ना?
यस सर.
हाँ चलो वेरी गुड. सो टुमारो वी विल एनालाइज व्हाट इज गोइंग टू हैपन एंड यू विल वेरी सरप्राइज कि इसको हम कैसे समझ सकते हैं. और थोड़ा सोचो क्या हो रहा है ये दोनों नंबर को लेकर के, है ना? ठीक है. देखते हैं क्या रिफ्लेक्शन कोफिशिएंट आपका आ रहा है. जस्ट ट्राई टू कैलकुलेट फ्रॉम. जरा चेक कर लो मैं नंबर सेम दिया हूं ना. यस. जस्ट ट्राई टू कैलकुलेट ऑल दिस थिंग. ठीक है. तो आप कैलकुलेट करो. देन टुमारो वी विल डिस्कस द एक्चुअल फिजिक्स व्हाट इज गोइंग टू हैपन. और इससे भी ज्यादा मजेदार होगा जब व्हेन ई इज लेस देन वी नॉट. व्हेन ई इज लेस देन वी नॉट व्हाट विल हैपन?
Tunneling will happen, sir.
Tunneling will happen. So how we can explain this thing, है ना? So
Yes,
uncertainty and statistical thinking will come into picture that we can analyze what is going to happen. Okay? चलो आज के लिए इतना ही रहने देते हैं. Thank you.
Thank you, sir. Good night, sir.
Good night.